Hey everybody, welcome to PASCO Laboratories. It's so nice to have you with us, and sorry for the delay. I think we had a little bit of trouble, but we're running on schedule again, and I'm JP here at PASCO Laboratories, and this week, Mackenzie, the P stands for pigments. That's exciting, isn't it?
It is.
It is. It's very exciting because it's not just any pigment. We're going to be looking at our friends chlorophyll, our friend carotene, and our favorite friend, the anthocyanins. Pretty exciting?
Oh, of course.
Very exciting. And if you think that's exciting, it gets even more exciting because we're going to be studying all of this through the great sciences of chromatography and spectroscopy. And ladies and gentlemen, just because you're with me and you're live, I'm alive, you're alive, you can get 5% off today on the things I'm going to show you. Just stick around for a couple minutes and I'm going to show you how you can get 5% off some of the devices I'm using all the way up until midnight tonight. So go get your wallet because I'm going to show you some neat things that you can do at home and some neat things that you can do with your kids in school. And remember, we're live. If you've got questions, feel free to write me my email, jkeener@pasco.com. I always take your emails, or you can just write us right now and we can answer them for you. But we take all of our questions from email that we do our shows on. And we got a very interesting question this week. Somebody wrote us, in fact, my family on the road said, we have Ernesto, Francisco, Laura, and Elena, and they said, please do something fun with leaves. Well, one fun thing you can do with leaves is throw them at each other. That's kind of fun, right?
Yes.
That's fun. Or we're in PASCO Laboratories, we're going to do some science. And to do science, we decided, why not get a good biologist to do that? So right here from PASCO Labs, we have our own Mackenzie. Mackenzie is going to have some fun with leaves. It doesn't look like you were throwing them. What are you doing?
Well, I was mashing them, so not quite as fun as throwing them, but
Mashing sounds fun.
the end result is incredibly fun. So what we're going to be doing is starting with an easy chromatography experiment that students can be doing at home. All you need is a little bit of filter paper, some leaves.
Coffee filter paper?
Coffee filter
Sure.
paper, yeah. This is just coffee filter paper from the store. And then these are 4 different leaves from the same tree out front of PASCO. And you're just going to take 4 different leaves and then take some scissors. And what you're going to want to do is cut them up into very small pieces. And then you're going to put them into little containers. I used mason jars at home. You don't have to use test tubes. And then you just add a little bit of isopropyl alcohol, which is just rubbing alcohol. You can use nail polish remover, just something that you want to extract those pigments with. And then you're just going to stir them around, mash them, just leave them for about 20 minutes, and then you'll end up with some pigmentation here.
Oh, that's really great because I see you had different colors leaves and now we've got some different colored pigments that are inside of each one of those containers. So that's a nice way to pull out our pigments. Word of the day, pigments. What can you do without that?
So then what we're going to do is take 1 drop, and so what I did was I cut the sealed edges and then I opened it and then I cut down horizontally to create strips, and then I just used some tape. You can use toothpicks. This is just a setup. And then what you will do is take 1 drop, and right at the very bottom where you draw a 2 centimeter mark, you're going to add a drop to the paper so that it's going to move up. And so what happens is that these different chlorophyll pigments and accessory pigments have different solubility limits. So when you add the alcohol to the very bottom of the paper, they're going to spread at different rates and they're going to go for different lengths. So what you do after about 20 minutes, you don't want to let it run through the whole paper, is you're going to get this really nice chromatography piece, which will allow you to see the different pigments that are present in your leaf. And then, of course, you would expect it to be different because as the leaves change during the fall, chlorophyll is being broken down and we're seeing these other pigments come through. So we're expecting probably to see a little bit different results between these. And so GP has a sample of one that we've done.
Yeah, we did. We took a look at that because this needs to run for a little bit, and we pulled those out. And if you take a look here, you can see that these did separate out. We've got chlorophyll A, we've got chlorophyll B, xanthophyll, which is great. And I'm assuming xanthophyll is responsible for this beautiful red?
It is. It is part of that. And then also the anthocyanins are going to be part of that too. So on the east coast of the United States, you see a lot of trees that turn bright red. So what's going to happen is that you see more of that on the East Coast than the West Coast. And so when we get red leaves on the West Coast, we get pretty excited about it because the production of the tree's pigments is different from species to species.
You biology people are far too excited about things like leaves, but
We
I am
are.
too. This is really very interesting because when you start studying leaves and chlorophyll, you get into some really interesting questions that you can challenge your kids with, or you can challenge your students with, or you can think about yourself. And here's my challenge for you, Mackenzie. This is pretty interesting. I've got some oils here. I've got some olive oil, I have some vegetable oil, and I have another sample of olive oil here. Which one of these do you think has more chlorophyll in it?
I would say the olive oil.
You would say that because when you look at it, it does kind of have a green color to it, doesn't
Yeah,
it?
a
And
little bit
so
of a hint.
let me show you where these things come from. Of course, olive oil comes from,
Olives.
and vegetable oil comes from.
Soybean.
Right, it's soybeans. Everybody thinks it comes from like maybe spinach, but it's not. Vegetable oil comes from the wonderful edible vegetable soybeans. And so it's actually soybean oil and olive oil. And of course, we would think that olive oil is going to have more chlorophyll, and it does. And for those of you doing experiments at home or working in school and you have a spectrometer like I'm going to show you, you want a good sample that's got great chlorophyll, just pick up a little bit of the olive oil here and you can get a great chlorophyll sample. I'm going to be using our spectrometer, the PS2600, the spectrometer, the wireless spectrometer that you see here, and I'm going to show you some samples. But before I show you the samples, Mackenzie, I'm going to give you some numbers to remember, and I'm going to show you some absorbances that are very important for us to remember, and we're going to see these again and again, even in a demonstration you're going to do later. So I've got chlorophyll, and I'm looking at chlorophyll A. It's going to be absorbing at about 416 nanometers, roughly. Remember that number. And chlorophyll also has a second absorbance, so 2 peaks we're going to be looking for. 2 peaks, twin peaks, 657 nanometers. We should exceed these 2 peaks with that. And here's something really fun, Mackenzie. Did you know the chlorophyll fluoresces?
I did not.
It does. And it's really a very interesting analytical technique to look at this fluorescence. In fact, if I shine light at 405 nanometers, if I shine light at 405 nanometers, which is purple, around ultraviolet purple, if I shine that at chlorophyll, it shines back. That's what fluorescing is. You give it one energy, it gives you back another. It shines back light at about 670 nanometers, which is purplish red. So I'm going to show that here if we can actually see that. So I'm going to show you, and let's see if we can't focus in on this. I think we need to shut this light off. If no one can give us a hand and turn that light, and I'm going to shine this here. And this is just vegetable oil, soybean oil, and I'm going to shine my light over that. And do you see any color changes at all, Mackenzie?
Not quite. Just looks like the light's reflecting a little
It
bit.
does. Just looks like the light's reflecting, and I don't see anything going on there. Now, let me take my sample of olive oil. Remember what we just saw, and I'm going to shine my light on here. Now, do you see anything different happening?
Oh yeah, it's definitely fluorescing.
Yeah, you see that red. It actually turns red in the light. You see that turn red? That's very interesting. So olive oil is fluorescing. It's fluorescing in the red. Now I'm going to take my third sample of olive oil. Let me try it one more time. And what do we see here?
Looks like the vegetable oil.
Right. Looks like the vegetable oil. Though it says olive oil, what's going on?
Maybe it's a mix?
Maybe it's a mix. And it is. When I take a look at this, it actually says it's a premium blend. Premium blend of?
Sunflower oil.
Right. So it's mostly sunflower oil. Sunflower oil also does not have chlorophyll. And so it may look green, but don't be fooled. This one is mostly sunflower oil. It is not fluorescing, so it does not have that great chlorophyll that we see fluorescing. And I have a picture here in case you weren't able to see it on the screen. We were able to do it here in the dark lab. On the left-hand side, you see what it looks like with that bright light. On the right-hand side, you see what it looks like with the purple or the infrared, the ultraviolet being shown at it, and you can see the big difference. That's a beautiful fluorescing,
That's a
right?
great photo.
And so we're going to see this ourselves. We're going to take a look at that. I'm going to open up my spectrometer here, which I've got in front of me, and I'm going to start collecting some data. I've already got it set up, already got it paired, and look at what I've done here, Mackenzie. I've already taken the spectrum. Remember those numbers I told you to remember? 416, well, I've mapped that out. And the other one around 670, somewhere around there, I've mapped that one out. And what I'm going to do, I'm going to take that vegetable oil, I'm going to put that vegetable oil into my sample, and let's see what happens. Here we go. Collecting some data. Let me expand this out for you. What do you see?
Looks like we're getting not a whole lot of action right there.
And no action here, right?
Nope.
We don't see the two peaks. The two spots I expected to see the peaks are missing. So let me take this sample out, and I'm going to take my olive oil that I have prepared, and I'm going to drop that into my colorimeter. Look what happens
Oh,
instantly.
man.
Let me scale this down so we can see a little bit better. Now what do you see?
I see our chlorophyll peaks.
Right. We got this one here at 416, and we have this one here at around 670, 600, right? 670. So we see the two chlorophyll peaks. And remember, I said that if this is chlorophyll, it will fluoresce. We saw the fluorescing, so let me take this, let me flip over. Our spectrometer has the ability to actually fluoresce at 405 nanometers. It's going to shine that in, and let's see what light is given off, if any. And look what happens. Let me scale this down. Look at that.
Wow.
What a beautiful peak we see here. A very nice peak where it's fluorescing, and we see that. And so this is chlorophyll. It is fluorescing. We can map that. We can track that. We can even use that for concentrations, apply Beer's law for those of you who might be doing that. And let me flip back here. Let me show you where those colors are, because you might be thinking, what colors am I looking at? So go back to my first spectrum and bring those colors in so you can see that we are definitely absorbing at the blue and at the red, which means we're transmitting at the green, which is why our leaves are green,
Yep.
right? Because they're absorbing, they absorb the blue, they absorb the red, but they transmit in the green, and that's why our leaves are green. And so I can do that experiment. It's great with the spectrometer, but we're really only looking at two very specific wavelengths. We're looking at the very specific blue and a very specific red, so I can do that also then with my colorimeter. Right?
We can.
Yeah, we can. We can have fun with colorimetry. So let me open up my colorimeter here. I've already got it paired up. You can see that my colorimeter has 100% of everything showing. It gives 1, 2, 3, 4, 5, 6 different specific wavelengths. And when I look at those, I'm going to open this up and I'm going to put in again, same as before, my sample of the vegetable oil. Put the vegetable oil in, and remember, we are not expecting to see anything really very exciting with the vegetable oil, and look, it's not. It is actually transmitting 100% across all the different colors. But if I take out my vegetable oil and I put in my sample of olive oil, look what happens.
Wow.
Yeah, we see a difference in the transmittance, and we would expect to see a difference in the absorbance, just like we did in the spectrometer. Let's come over here and take a look at the absorbance. Here it is.
Wow.
And remember those two colors that we talked about. In the purple, we saw a peak. In the red, we saw a peak. And we can see that here on my colorimeter too. So whether you're using the spectrometer or the colorimeter, you're able to do some really neat experiments with your kids, taking a look at chlorophyll, taking a look at the different pigments that are there. And you might be thinking, how can I get that lab? We have them for you already, actually. The experiments that I was showing you with the spectrometer, which is analyzing the absorption, analyzing the spectrum of leaves, you can find that right at our website. If you go to the spectrometer website and open up the experiments tab that you see, you will find all of these experiments and more available to you. Or just go to our library, the experiment library, and if you type in colorimetry, you will see a whole list, or spectroscopy, colorimetry or spectroscopy, you're going to see a whole list of great activities that are available and free to you. And Mackenzie, can they get the teacher answers too?
I believe so. All you need is a PASCO account and to log into your PASCO account, and you should be able to access it.
Absolutely. We've got a question coming in. Brett.
Yes, how do you calibrate the colorimeter?
Ah, great question. Right. So the colorimeter does have to be calibrated, and it automatically calibrates as soon as you open up. Same with the spectrometer. The colorimeter, when you turn it on, it says, hey, I think you need to calibrate. And you push a button and it calibrates. The spectrometer, it has two buttons at the bottom. It asks you to calibrate. You calculate in the light, you calculate in the dark, just like we do with all spectroscopy. And then you've got to calibrate it down to 0. So this is automatically built into the colorimeter and tells you before you start using the spectrometer, hey, it's time to calibrate. Great question for you. So now that you've seen what I can do with these two different things, I want to go back to Mackenzie and take a look at what she's able to do with some of her stuff. So Mackenzie, what are you thinking you can do here?
Yeah, so this is my favorite part of the fall season, doing experiments with leaves. This is my favorite, by far, coolest part of doing it. And with the spectrometer, it's really easy. You can take it anywhere you want. I did this experiment at home. So what you can do is take the same pigments that you used for your chromatography. Again, you're just going to cut your leaves up. You're going to put them into a tube separately by color, and then you just apply a little bit of acetone or rubbing alcohol to extract those pigments. So for my blank, we already had a blank going over here. Can I use that, sir?
Let's see.
Oh, it's in your colorimeter?
Yes.
Okay, thank you.
Nope, that's the
th-
yellow. Here's
That's
the
your blank. Okay, so we're going to do a blank first. And so we're just going to do this. And I like to run this. Let's do, just leave them actually. So we'll do this and stop it. And so we shouldn't see very much absorbance on the blank.
Good. As it should be.
Of course, no chlorophyll in water. Hopefully, otherwise you need water.
Hopefully, yeah, your water's coming over a tree.
So this is the first one. This is going to correspond with the all green leaf. And what we're going to do is put this into the spectrometer.
Okay.
And we're going to press record. And then we're going to align
Span
this
that
a little
out.
bit
So this
better.
is solution 10. And remember those peaks that we were looking for? Seeing them again.
Yep.
Here's that beautiful peak at 650. There's my other one. We see both peaks here, able to label that nicely. We've got that peak at 650. We've got another
one
peak
right
right
here.
there. So we've got our twin peaks of chlorophyll are showing up. But what I'm noticing from your different samples is the amount of chlorophyll actually changes over time.
Yes. So during the fall, when your leaves are changing colors, what's happening is the chlorophyll is being broken down. So as the chlorophyll breaks down, you're going to see more beta carotene. You're going to see more carotenoids in general. And so you're going to get these different colors coming through. So these represent the oranges, the yellows, and the reds that you see during fall. So some leaves will produce the pigments for red, but most of the time it's just the chlorophyll being broken down that causes these pigments to come through. So as this changes, we should expect to see less chlorophyll in each leaf sample. And then sometimes you can also see peaks of the accessory pigments as chlorophyll becomes less prevalent. So we'll see if we get any of those.
Okay, so we'll take out the chlorophyll sample. We'll put in one now that is turning a little bit yellow, more of our yellowish color leaves that we have here that we see in the fall. And of course, as the chlorophyll starts to decrease, we should see a drop in chlorophyll. Let's see what you got.
All right, let's put that in there. And we'll start this.
Okay, that's solution 11, and okay, and
let's do this.
see.
Oh, that showed all of them. So we got our 650 peak again, but it's lower than the previous one.
it is. So we can see a much difference in the height of the peaks. Of course, we could compare those two peaks. We have to get rid of some of those numbers. We were kind of experimenting beforehand,
Right.
but we can see that there is a big decrease. Now, as we continue on throughout the seasons, as Mackenzie was explaining to me, we actually get to the point where the chlorophyll practically degrades altogether.
Yes.
That's, those beautiful red leaves that we see outside. What happens there?
So what happens is as the seasonal senescence progresses, we're going to see almost no chlorophyll in the very last sample. So we should see these peaks get much lower. As the chlorophyll is being broken down, the reason that this is done is so that the leaf isn't expending energy and absorbing energy when it doesn't need to be. It needs to be spending that energy on conserving. So what happens is these pigments come into play to protect the chlorophyll in the leaf from being oxidized and by free radicals. So they protect against free radicals, which is why a lot of these are also antioxidants.
Sure, Mackenzie.
So this
right?
is the
right. Free radicals and sure.
So
Not going to be oxidized.
This is the third one. So what we're going to do is pop this in the spectrometer, and we're going to record some data.
Oh wow! And look at
much
this. So just in a rapid comparison, in fact, the peaks are gone.
Yeah,
when you
I
come
heard-
right down to it. So my chlorophyll peaks are gone altogether on the spectrum, and I can see very rapidly that the chlorophyll on the same tree, taking a look at leaf samples from the same tree over time, we can see the degradation of chlorophyll. And that's a very interesting experiment that you're able to do there.
It is a simple, fast experiment, and it's very interesting for the timing, and it can be applied to environmental science, biology. It even has some physics implications if you want to talk just about the electromagnetic spectrum.
And also, I would imagine if you knew different concentrations, you could probably even determine concentrations of a sample.
Oh, absolutely, yes.
Beer's law, right? And so that's definitely what you would want to do with your spectrometer or with your colorimeter. You'd want to take an opportunity to do some Beer's law experimentation and take a look at concentrations of samples. And remember what I told you, kids, if you stuck around with me to the end, I was going to give you an opportunity to give 5% off You know, we're coming towards the end of the season. We're coming towards Christmas. Everybody wants one of these under their tree, don't they?
Of course, I want one under my tree.
And you may get one because it's 5% off, and all you got to do is remember the word for today, which was
Pigments.
pigments, right. So if you reach out to our sales guy, Mr. Pigment himself, if you reach out to Isaac and say, hey, Isaac, I remember pigment, and it's still today. Today is 10/15/2020, and you use the word pigment, he's going to give you 5% off, either on this great spectrometer or this wonderful wireless colorimeter. You can get one for home, and you can start doing these demonstrations for your kids, or you can work with your kids, or you can do some distance learning with your kids, just like we're doing with you today. It's a great opportunity, right?
Absolutely.
And so we have all of these activities for you. They're free. The entire set of biology experiments for you is free. All you have to do is go to pasco.com, take a look in our experiment library, and you can find all of these activities that we're talking about. Everything is available to you for free and 5% off these great tools. And what do you think about that?
I think it's great.
I
How
think
could you
it's good
pass
too.
that up?
You cannot pass that up. So ladies and gentlemen, we really thank you for joining us today. We had a great time. Mackenzie, thank you for
Thank you for
joining me.
having
Had a
me.
great time. And to all of you at home, we wish you the best of luck, great teaching, and good day.